let's read through this thing. In right triangle ABC below, I cross out above and put below because my diagram's actually below. Yours is not though. So in right triangle ABC, side EF is parallel to side AC, and F is the midpoint of BC. What is the area of the shaded rectangular region? All right, first things first, let's ask our 5 questions. Who, what, when, where, and how. Notice we want to ask the who question last, so I put a little arrow there to show that that's going to be the last question we ask. So the what question, what kind of problem is this? Unfortunately for you geometry haters out there, this is a geometry problem. And we know this why. Well, first of all, we have a figure, that's a dead giveaway. Oh, and then we have some geometric language like triangle, midpoint, area, yeah, geometric language. So the when question, how much time do we have left on this section? Well, as you're going through these practice problems on your own and you're timing yourself, this is number 17 out of 20 in this particular section. So chances are you're probably running kind of short on time at this point. And since it's question number 17, that answers our where question. It's number 17, so we can assume this is going to be a hard problem because it's at the end of this section. So lastly, not lastly, second to lastly, the how question. What's our method for solving this? Well, unfortunately, a lot of times these geometry problems, we kind of gotta solve them geometrically, the way we maybe solve them in a geometry class. The one thing we can use to our advantage is the fact that we can assume these diagrams are drawn to scale unless we're told that they're not. So that can really be helpful because we can get around having to use geometric theorems and we don't have to prove anything. If something looks like it's a certain length, we can assume that it is. So that'll be real helpful, and we'll probably use that even in this problem right here. So the who question is a question that only you can answer for yourself. Do you want to do this problem, or do you want to skip it given your answers to the other 4 questions? So since this is a tutorial, our answer to the who question is always going to be me, us. Yes, we are going to do this thing. So let's do it. So let's talk about methods here. How are we going to solve this? Well, the best thing to do in a geometry problem is to start out by marking your givens on the diagram. This is a really good place to start. So let's look at our givens. Well, EF is parallel to AC. We can definitely mark that. And I'm going to use these little greater than symbols to show that 2 sides are parallel, but you can use whatever the heck you want to use as long as you know what it means. And then we're given that F is the midpoint of side BC. Well, midpoint just means it splits the side in half. So that tells us that BF is congruent to FC, and I'm going to mark that with these little tick marks. Alright, so what are we going to do to solve this? Let's first talk about strategy. Remember, we're solving for the area of this rectangle, EF. And for simplicity, and as we talk about this, I'm going to go ahead and mark some more points just so that it makes it easier to talk about here. I'm just going to call this point G, this point L, and this point P. I don't know why I used those letters. It's not like they even have any meaning, but we're going to go with that. Okay, so we're talking about finding the area EFGP now. In order to do that, we're going to need to know some lengths. We're going to need to know EF, and we're going to need to know GF, or FG. So that's our goal. We really want to find this, and we want to find this. So what can we use to do that? Let's look at our givens. I want you to look at the outer triangle here, the big one, ABC. This is a right triangle. It's also an isosceles triangle, and we know that because we're given that AB and BC are both 10 root 2. And what we know about isosceles triangles is that the angles opposite the equivalent sides are also going to be equivalent or congruent. And my pen is running out of ink here, but I'm going to show that those are congruent using those tick marks again. So those two angles are congruent. Does that help us? Well, maybe. It's hard to see at this point if it'll help us or not, but I think it will. Because since we know that ABC is a right triangle, we can actually solve for angle A and angle C. If those two angles are equal, well, we know that all three angles in a triangle have to add up to 180 degrees. So angle A plus angle B plus angle C has to equal 180 degrees. And we know that angle B is 90 degrees, which tells us that A and C have to add up to 90, and since they're equal, both of them have to be 45. Make sense? All right. So those are both 45, and I can even mark that on the diagram if I want. 45 degrees and 45 degrees. Anything you can mark on the diagram, I say do it. The more, the better, as long as it doesn't start to get so cluttered that you can't read it, which is kind of how mine is looking. So hopefully yours is a little bit neater. All right, so if that's 45 degrees, well, now I want you to look at triangle FCG. What do we know about that triangle? Well, first it's a right triangle. We know that that angle, angle FGC, is a right angle. So actually we can solve for this angle right here, CFG, this angle right in there. We can solve for that. Again, we know that three angles of a triangle have to add to 180 degrees, so we have 90 here and 45 here, so we know that this one has to be 45. And what do we have here? Ooh, we have a special right triangle. A special right triangle where two sides are 45 degrees and the other one is 90, hence the right triangle. So special triangles are great because as long as we know one side, we can solve for the other two sides. Well, do we know one side? Well, yeah, we do actually, because we were told that F was the midpoint of BC, which means it splits BC in half, and if BC is 10 root 2, then half of that is just 5 root 2. FC is 5 root 2. And by that same logic, actually, BF is 5 root 2, so we could mark that also if we wanted to. Alright, so here's the cool thing. If we know that FC, the hypotenuse of triangle GFC, is 5 root 2, we know based on our formulas that in a 45, 45, 90 triangle, if the hypotenuse is x root 2, then both legs of the triangle are x. So in our case, if the hypotenuse is 5 root 2, we know the legs are just 5. 5 root 2. So you can see already that this is going to be really helpful because guess what? We just found LG. Actually, we didn't. Sorry, jumping the gun. We just found FG to be 5. And we just found GC to be 5. Alright, so let's see what we can do from here. First of all, we can pretty much solve this now based on the fact that this thing is drawn to scale. And it looks like, judging from the diagram, not so much my diagram, but the diagram in your book, definitely looks like FG and LG are the same. And if it looks like it does, we can assume that those two things are equal. And I know you're probably not used to assuming things. You're probably discouraged from doing so in your geometry classes and even in your algebra classes. We never want to assume, but on the SAT you do. And why? Because assuming saves a ton of time. We don't want to have to calculate something if we can just look at it and say, yeah, that's the case. So you know what? We're going to say LG is 5. And guess what? We now have enough information to solve this thing because we can solve for this half of the rectangle right here. It's actually a square, and that area is just 5 times 5, or 25. And it's actually symmetric to that area right there, which is also going to be 25. And we could prove that, and that might take a couple of minutes, or we could assume that based on the fact that the diagram looks like those two things are equal. So if the area of F, G, L, and whatever this is, let's call it M, If the area of FGLM is 25 and the area of EPLM is 25, then the total area is 25 plus 25 is 50, and that arithmetic was real tough. But hey, we see that the answer we got is one of the answer choices, and that's always a good sign. So we're going to go with C and cross our fingers and hope that that's the right answer. And I think it is, so I think we're good to go.